The 13th term of an arithmetic progression is 27, and the 7th term is 3 times the second term. Find the first term, and then B, find the common difference, and then C, find the sum of the first 10 terms. The general formula for finding the nth term of an arithmetic sequence. An is equal to a1 plus 2 bracket n minus 1 d. So he says that the 13th term is 27. So let's find A13. So A13 is equal to A1, then plus n. N is 13. 13 minus 1 is 12. So 12D. This is A13. However, the question says that A13 is 27. So this implies that A1 plus 12D is equal to 27. So this becomes our equation 1. And then the question also says that the 7th term is 3 times the second term. So let's find the second term, A2. A2 is equal to A1 plus into bracket n. N is 2 minus 1 is 1. 1 times d is d. So A2 is A1 plus d. Then he says that the 7th term, so let's find A7. A7 is equal to A1 plus n. N in this case is 7. 7 minus 1 is 6. So A1 plus 6d. And he says that the 7th term is 3 times the second term. So it means that A7 is equal to 3 times A2. So this implies that we should multiply this A2 by 3 and equate it to A7. So this implies that A1 plus 6D is equal to 3 times A1 plus D. So A1 plus 6D is equal to 3A1. I'm expanding this. 3 times A1 is 3A1 plus 3 times D is plus 3D. A1, I'm taking 3D to this side and bringing A1 to this other side. So 6D minus 3D will give 3D equals 3A1 minus A1 equals 2A1. So 3D is equal to 2A1. However, so this becomes equation 2. However, from equation 1, we know that A1 plus 12D is equal to 27. This is equation 1. So we are looking for 2A1, and therefore let's multiply equation 1 by 2. So 2A1 plus 2 times 12 is 24. D is equal to 2 times 27 is 54. So this becomes equation 3. And therefore we can substitute this equation because it says 2A1 is equal to 3D. So this 2A1 we replace it with 3D. So 3D plus 24D is equal to 54. So 3 plus 24 is 27D equals 54. So we are saying that 27D is equal to 54. So let's divide through by 27. Divide here to by 27. So this and this cancels. At the end of the day, D is equal to 54 divided by 27. And that is 2. So D is equal to 2. So since we know D is equal to 2, from equation 2, we said that 3D is equal to 2A1. So 3 times 2 is equal to 2A1. And therefore A1 is equal to 3 times 2 divided by 2. So this 2 and this 2 can cancel out so that A1 is equal to 3. So the first term, A1, is equal to 3. The common difference D is equal to 2. Now the question says we should find the sum of the first 10 terms. So let's write the formula for the sum. Sn equals n over 2 into brackets 2a1 then plus into bracket n minus 1 d. So n is 10 divided by 2 equals 2 times a1. We got a1 as 3. So 3 plus into bracket n is 10 minus 1 is 9. Okay, so the better still, let me write it. 10 minus 1 times d is 2. So times 2. 10 divided by 2 is 5 times 2 times 3 is 6 plus 10 minus 1 is 9. 9 times 2 is 18. So this is equal to 5 times 18 plus 6 equals 24. And 24 times 5 equals 120. The sum of the first n terms of a linear sequence AP is minus 27.5. If its first term and common difference are 1 and minus 1 over 4 respectively, find the positive values of n. So the first term a1 is equal to 1. The common difference d is minus 1 over 4. Then he says that the sum of the first n terms, so Sn, is equal to minus 27.5. So we are supposed to find the number of terms. Therefore, let's write the general formula for the sum of an arithmetic sequence. So Sn is equal to n over 2 into brackets 2a1 plus into brackets n minus 1 d. So everything has been given. So however, Sn is equal to minus 27.5. This is the same as minus 55 over 2. So let's substitute the values inside. Sn is minus 55 over 2 equals n, which is what we are looking for, divided by 2 times a1. a1 is 1, and plus n minus 1 times the common difference. The common difference is minus 1 over 4. So times minus 1 over 4. So let's multiply through by 2. So we multiply here by 2. Multiply this side 2 by 2 so that this 2 and this 2 can cancel out. And then this 2 and this 2 can also cancel out. So at the end of the day, minus 55 is equal to n times 2 times 1 is 2 plus into brackets. Let me expand this bracket. Minus 1 over 4 times n. So this becomes minus 1 over 4n. And minus 1 over 4 times minus 1 becomes plus 1 over 4. So let me multiply through by n. So we get minus 55 is equal to 2 times n is 2n. Then n times minus 1 over 4n becomes minus 1 over 4n squared. Then n times 1 over 4 becomes plus 1 over 4n. So minus 55 is equal to 2n plus 1 over 4n equals 9 over 4n minus 1 over 4n squared. So let's multiply through by 4. So this becomes 4 times minus 55 equals 4 times 9 over 4n, then minus 4 times 1 over 4n squared. So that's 4 times minus 55 equals minus 220, which is equal to this and this can cancel out. This side and this side can cancel out. So it becomes 9n minus n squared. So let's bring the minus 220 to the side. So it becomes 220. So this becomes 220 plus 9n minus n squared is equal to 0. So let's multiply through by minus 1. So it becomes n squared, then minus 9n minus 220 is equal to 0. So we see that in this case too, it is of the form ax squared plus bx plus c is equal to 0. And therefore in this case, a is equal to 1, b is equal to minus 9, and then c is equal to minus 220. So based on the quadratic formula, which says that x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, you can say therefore n is equal to minus b, which is minus 9, then plus or minus square root of b squared minus 9 squared minus 4 times a is 1 times c minus 220 divided by 2a, 2 times a is 1. So n is equal to minus 9 is 9 plus or minus square root of minus 9 squared is 81. Then minus 4 times 1 is minus 4 times minus 220 equals plus 880 divided by 2 times 1 is 2. So n is equal to 9 divided by 2 is 4.5 plus or minus square root of 81 plus 880 is equal to 31 divided by 2. So n is equal to 4.5 plus or minus 31 divided by 2 is 15.5. So n can only be a positive integer, and therefore n is equal to 4.5 plus 15.5, and then 4.5 plus 15.5 is equal to 20. These 3 terms of an infinite exponential sequence GP are 2x minus 1, x plus 1, x minus 1, where x is greater than 0. Calculate A, the value of x, B, the constant ratio, and C, the sum of all the terms of the sequence. So the arithmetic sequence is 2x minus 1, then we also have x plus 1, and we have x minus 1. But the question says it is a geometric progression. So therefore, since it is a geometric progression GP, then it means that the common ratio between these two is equal to the common ratio between these two. So how do we find the common ratio between these two? R1 is equal to x plus 1 divided by 2x minus 1. And then let's find the common ratio here. So this is R1 and this is R2. So R2 is equal to x minus 1 divided by x plus 1. So since R1 is equal to R2, since it's a geometric progression, and therefore x plus 1 divided by 2x minus 1 equals x minus 1 divided by x plus 1. So let's cross multiply. So this becomes x plus 1 times x plus 1 equals x minus 1 times 2x minus 1. So let's multiply. So this x times x is x squared, then x times 1 is plus x. 1 times x is plus x, and 1 times 1 is plus 1 equals x times 2x is 2x squared. Then x times minus 1 is minus x. Minus 1 times 2x is minus 2x. And minus 1 times minus 1 equals plus 1. So that plus 1 can cancel out on both sides. So x squared, then x plus x is 2x equals 2x squared. Then minus x minus 2x becomes minus 3x. So let's take these terms and bring it to the right hand side of the equation. So it becomes 2x squared, then minus this x squared, then minus 3x, then this term minus 2x equals 0. So we get 2x squared minus x squared is equal to x squared. Then minus 3x minus 2x becomes minus 5x equals 0. So continuing from here, x squared minus 5x is equal to 0. So let's factorize x out. We allow it x minus 5 equals 0. And therefore, the values of x are x is equal to 0 or x is equal to 5. However, this question puts a constraint on the values of x that we can have, because it says that one of the constraints are x is greater than 0. So since x is greater than 0, it implies that x cannot be equal to 0, and therefore x is equal to 5. So let's use x equals 5 to find the members of the sequence. So the first member is 2x minus 1. This is equal to 2 times 5 minus 1. 2 times 5 is 10. 10 minus 1 equals 9. The second one is x plus 1. 5 plus 1 is 6. So we have 9, we have 6. Then x minus 1. 5 minus 1 is 4. So the sequence is 9, 6, 4. Then the second part of the question says we should find the constant ratio. R is equal to 6 divided by 9. R is equal to 6 divided by 9. 6 divided by 3 is 2. And then 9 divided by 3 is 3. So R is equal to 2 over 3. And then the last part of the question says the sum of all the terms in the sequence. So remember that sum to infinity, because the question says it is an infinite exponential sequence. So sum to infinity is equal to a1 divided by 1 minus r. a1 is equal to 9, and therefore sum to infinity is equal to 9 divided by 1 minus the constant ratio, which is 2 divided by 3. So this is equal to 9 divided by 1 minus 2 over 3 is equal to 1 divided by 3. So this is equal to 9 times 3 divided by 1, which is equal to 27. The first, fifth, and 10th terms of a linear sequence are in geometric progression. If the sum of the second and 8th terms of the linear sequence is 30, find A, the first term, and then B, the non-zero common difference of the linear sequence. So he says that the first, 5th, and 10th term are in linear sequence. So let's find the first term is A1. What is the 5th term? A5 equals A1 plus 4D. And 10th terms, so A10 is equal to A1 plus 9D. He says that A1 and then A1 plus 4D and A1 plus 9D are in geometric sequence. So since they are in geometric sequence, it means they have a common ratio. So let's go ahead and find the common ratio between these two, and this term and this term is equal to the common ratio of this term and this term. This question is similar to the previous example. So therefore, the common ratio between these two is A1 plus 4D divided by A1. And this is equal to the common ratio between these two also is A1 plus 9D divided by A1 plus 4D. So let's cross multiply like this, so that we have A1 times A1 plus 9D is equal to A1 plus 4D times A1 plus 4D. So let's distribute. This becomes A1 times A1 is A1 squared. Then plus A1 times 9D becomes 9A1D, because A1 times A1 is A1 squared. Then A1 times 4D becomes plus 4A1D. Then A1, then 4D times A1 becomes plus 4A1D. Then 4D times 4D is equal to 16. So it becomes plus 16D squared. So let's bring all of these terms. So A1 squared and A1 squared can cancel out, so that we will have 9A1D equals 4A1D plus 4A1D equals 8A1D plus 16D squared. So let's bring this 9A1D to the right hand side. Or better still, I could take 8A1D to the left hand side, so that we have 9A1D minus 8A1D equals 16D squared. So 9A1D minus 8A1D becomes A1D equals 16D squared. So this is our equation 1. However, the question also says that the sum of the second and eighth terms of the linear sequence is 30. So let's find A2. A2 is equal to A1 plus D. And then eighth term, A8, is equal to A1 plus 7D. And it says that their sum is 30. It means that A1 plus D plus A1 plus 7D equals 30. So A1 plus A1 is 2A1, and plus 7D plus D is 8D equals 30. So let's divide through by 2, so that this becomes divided by 2, divided by 2, and this one 2 divided by 2. So we are left with A1 plus 4D. 8 divided by 2 is 4 times it becomes 4D equals 30 divided by 2, 15. So this is our equation 2. So let's multiply through by D, so that A1 times D becomes A1D plus 4D times D becomes 4D squared equals 15 times D is 15D. However, remember that we said from equation 1, A1D is equal to 16D squared, and therefore we are going to replace this A1D with 16D squared. So it becomes 16D squared plus 4D squared equals 15D. So 16D squared plus 4D squared equals 20D squared, then minus 15D equals 0. So let's factorize 5d out. So if we factorize 5d out, we are left with 4d minus 3 equals 0. So that there are two values. It's either d is equal to 0 or d is equal to 3/4. However, the common difference, d, cannot be equal to 0. And since d cannot be equal to 0, d is only equal to 3/4. So we found the value of d. Let's put d into equation 2 and find the value of a1 the first time. So a1 plus 4 times d, and then d is 3/4 equals 15. So that this 4 and this 4 can cancel out. So a1, so this a1 plus 3 equals 15. So a1 is equal to 15 minus 3, which is equal to 12. The sum to infinity of an exponential sequence GP with a positive common ratio is 25, and the sum of the first two terms is 16. Find the fifth term and then the sum of the first four terms. So sum to infinity is equal to 25. And the question also says that the sum of the first two terms is 16. And okay, for a geometric series, it's given us a1 times into brackets 1 minus r exponent n divided by 1 minus r. So s2 is equal to a1 and times 1 minus r squared divided by 1 minus r. So in simplifying further, s2 is equal to a1 and times 1 minus r squared is difference of two squares. So we have one bracket 1 minus r times in another bracket 1 plus r divided by 1 minus r. So that this 1 minus r and 1 minus r can cancel out. So s2 is equal to a1 times 1 plus r. So now the question says that, so let's also find the sum to infinity. So the question says that the sum of the first two terms is 16. This implies that a1 times 1 plus r is equal to 16. Then the question says that the sum to infinity of the exponential sequence with a positive common ratio is 25. So let's write the formula for sum to infinity. It's equal to a1 divided by 1 minus r. And he says it's 25. It means that 25 is equal to a1 divided by 1 minus r. And therefore a1 is equal to 25 times 1 minus r. So this is equation 1 and this is equation 2. So all we need to do is to come and replace this a1 with 25 times 1 minus r. So we are getting 25 times 1 minus r and times this, which is 1 plus r, equals 16. So that this becomes 1 minus r times 1 plus r equals 16 divided by 25. So that 1 minus r plus times 1 plus r is difference of two squares. So it becomes 1 minus r squared equals 16 over 25. So making r squared the subject, is equal to 1 minus 16 over 25. So r squared is equal to 1 minus 16 over 25 is the same as 9/25. So finding the square root on both sides, you see that r is equal to the square root of 9 is 3 divided by the square root of 25, that is 5. So since we have found a common ratio, remember that from equation 1, we found a1 as a1 equals 25 times 1 minus r. So we said the common ratio r equals 3/5. So let's substitute 3/5 to find the value of a1. So a1 is equal to 25 times 1 minus r, which is 3/5. And so a1 is equal to 25 times 1 minus 3/5 is 2/5. And 25 divided by 5 is 5. So a1 is equal to 5 times 2. And therefore a1 is equal to 10. So the question says in the B part that we should find the fifth term. Remember that an is equal to a1 r exponent n minus 1. So the fifth term a5 is equal to a1 times r exponent 5 minus 1 is 4. So we can substitute the values. So a5 equals a1 is 10 times the common ratio, which is 3/5, exponent 4. And then a5 is equal to 1.296. So a5 is approximately 1.3 in terms of 1 decimal place. Then the last part of the question is to find the sum of the first 4 terms. But we know that S4 is equal to a1 times into brackets 1 minus r exponent n, which is 4, divided by 1 minus r, which is 1 minus r. So S4 is equal to a1 is 10 times 1 minus r, r is 3/5, exponent 4, divided by into 1 minus 3 divided by 5. And then S4 is equal to 21.76, which is approximately 21.8 in 1 decimal place. Express 0.45 plus 0.0045 plus 0.00045 in the form of a divided by b, where b is not equal to 0, where a and b are integers. So you can see that this is sum to infinity. So we have 0.45, then plus 0.0045, then plus 0.00045 up to infinity. So the first term a1 is equal to 0.45. Then the common ratio r is the second term, which is 0.0045 divided by 0.45. And this is equal to 0.01. So sum to infinity is equal to the first term a1 divided by 1 minus the common ratio. So a1 is 0.45 divided by 1 minus 0.01. This is equal to 0.45 divided by 0.99. And this is equivalent to 45 divided by 99. And then 9 divided by 45 divided by 9 is 5. And 99 divided by 9 is 11. So at the end of the day, the sum to infinity equals 5 divided by 11. The sum of the first and the last terms of a linear sequence AP is 42. If the sum of all the terms is 420 and the second term is 4, find A, the number of terms, B, the common difference, and C, the last term of the sequence. So let's write the formula for finding the sum. Sn equals n over 2 to bracket 2a1 and plus to bracket n minus 1d. So the last term, al, is equal to a1 plus n minus 1d. Therefore, this Sn can be written as the sum equals n over 2. Then to bracket 2a1 becomes a1 plus a1 plus to bracket n minus 1d. So that all of a1 plus n minus 1d, here's a1 plus n minus 1d, which is al, the last term. So the sum Sn equals n over 2 into bracket the first term plus the last term. So Sn equals, the question says that the sum of the first term and then the last term of the sequence is 42. So therefore Sn is equal to n over 2 times 42. The question says that the total sum is 420. So this implies that 420 is equal to 42 divided by 2 is 21. So 21n. If we divide 2 by 21, we find out that n is equal to 420 divided by 21, which is 20. So the value of n is equal to 20. And then he says we should find a common difference. However, he said the second term is 4. So the second term, a2, equals a1 plus d. And so this implies that a1 plus d is equal to 4. So since we know the total sum, together with this equation, let's write an equation in terms of a1 and d. So we said the sum Sn is equal to 420 and this is equal to n. The total number is 20. So 20 divided by 2 into bracket 2a1 plus n minus 1, and n is 20, so plus 19d. So 420 is equal to 20 divided by 2 is 10, then times 2a1 plus 19d. So let's divide through by 10. Find out that 2a1 plus 19d. So this is our equation 2. And then this portion is equation 1. So let's multiply equation 1 by 2. We multiply equation 1 by 2. 2 times a1 becomes 2a1. Then plus 2 times d equals 2d, which is equal to 2 times 4 is 8. So this becomes equation 3. So let's find equation 2 minus equation 3. So 2a1 minus 2a1 is 0. So we get 19d minus 2d equals 42 minus 8. So 19d minus 2d is 17 because 42 minus 8 is 34. So dividing through by 17, we find out that D is equal to 2. So since we found the common difference, then we can put the value of D into equation 4. Since we found D as 2, we can put the value of D into equation 1 and find A. So let me just solve it here. So A1 plus D, which is 2, is equal to 4. So A1 equals 4 minus 2, which is equal to 2. So the first term is 2, and then the common difference is also 2. Now let's simplify the last part of the question, which is the last term of the sequence. However, remember that the question says that the sum of the first term and then the last term is 42. So in other words, A1 plus AL equals 42. A1 is 2, which is the first term, plus AL equals 42. So the last term, AL equals 42 minus 2. So AL, which is the last term, equals 40.